I know Colby sat back there. He's got that, what is it called, photographic memory or whatever, so he sees them and he just has them all memorized, so he doesn't really have to write them down. But the rest of you probably ought to write them down when we get to them. When you're looking at interest, again, you got to think about the account that you're dealing with. If it's a credit card account, is the interest helping or hurting you? If it's a credit card. Hurting. If it's a savings account, is the interest helping or hurting you? Helping. When you think of that, you got to know that that company, that bank, that loan company, that credit card company, whatever it is, are they in the business to help you? No. So whatever goes against you and it's going to be better for them, that's the way it's going to be set up. So a credit card account, when it has compound interest, that interest is probably compounded as many times as physically possible. If they could compound it every second, they would. All right? Usually it's daily. A savings account where the interest is helping you isn't compounded daily. It's compounded usually monthly or quarterly, because that's money that they have to give you. They don't want to give you any more money than they have to. Now they want, if it's a loan, they want to take as much money from you as they possibly can. So that's going to be compounded more often. The interest is going to be added on there more often, because that's more money they can make from you. So compound interest is interest earned not only on the original principal, but also on any interest earned during the previous interest period, or periods. So what you're doing there is you're earning interest on interest if it's compounded. So if it's a credit card account, then they're earning, you go today and you charge $5 for a soda and a bag of chips at the gas station. Not only are they going to make that $5, but they're going to make the interest on that. So if they charge you 2 cents interest today, then tomorrow, if you haven't paid all that money back, now they're not charging you interest on the $5, they're charging you interest on the $5.02. And then the next day they're charging you interest on the $5.02 plus the other interest. And it builds up fairly quickly. Speaking of which, Matt, that we were talking about last time, I sort of lied to you because I said 47,000. That was wrong. I forgot to add on the 13,000. So the total amount would have been 60,840. Right, $60,000. If we compounded the interest, if we took compound interest, the total after what we do when you turn 65 after like 47 years or something, the total would have been $414,926.72. So remember that. Ebersole, when he was sitting in the spot that you guys are in, actually I was a couple years older than you guys because I was in college. I had a math teacher tell me, hey, make an account. You don't have any, at that time when I was first getting my job, I didn't have any kids or anything. Make an account. Put $100 in there every pay or so, just and leave it in there. By the time you're ready to retire, you'll have probably 1.5 million or so in that account. There was a quiz too that we did that I'll get to you in a minute. So you get out of here, and hopefully you don't do anything stupid and go out and start having kids the day you leave here, any of you, because that's not what you want, because they're very expensive and pain in the butt. Pain in the butt. Put some money in an account and start saving and just leave it in there and don't mess with it. And after a while, what I was telling Matt there is we had that, I was talking to him about saving money, and I figured it up. And after like the first 10 years, Matt, didn't seem like nothing. After the first 15 years, started getting a little bigger. Then when we got down here to like year 25, year 30, then it started growing really, really quick. The interest at year 30 was over $10,000 per year in interest. So you were earning $10,000 per year on a $13,000 investment. By year 40, you were earning over $20,000 per year for that $13,000 investment. And that's just, just leaving it set there. And that's what a lot of people, a lot of these real rich people, what they can do is they just live off they leave the account go, and they just live off the interest that they draw from that stuff. So when you hear stuff like Donald Trump has filed bankruptcy 15 times and so on and so on, well, that's because he can do all that and still live off the interest of some other account that he has and live better than you or me ever can. So compound interest, interest earned not only on the original principal but also on the interest that's added in each time. A period, this is important as far as a period, what a period is. A period is the amount of time, whether it's annually, quarterly, monthly, daily, etc. You got to know, and we've been going over this all year long, so if it's annually, if it's just annual, then that means one time a year. If it's quarterly, and quit working. If it's quarterly, how many times a year is that? If it's monthly, how many times a year? Good. If it's daily, how many times a year? 365. You got to know those. All right? Most of the stuff, again, it's going to be quarterly, monthly, maybe daily. One of those three, usually annually. Well, if it's annually, then that's just simple interest. That's nothing. That's what we were just doing. These formulas. Separate these formulas when you write them down. And I'll explain why. Please make sure you write that top formula correctly. I know Caleb's looking at this and he's thinking, well, I like that bottom formula better because it's a lot shorter in there. That's true, it is. And I'll explain why I don't like the bottom formula here in a minute. if I remember, you're right. That quiz. What were the numbers?
3 through 22 or something? 7 through 22.
7 through 22?
Yep.
Thank you. There's the quiz, and this is the chart that we're going to use here in a couple minutes. What's the date today?
The first.
First?
Yeah. So your days and 12 days.
$200.
Again, make sure you don't lose these formulas. I know that Caitlin can,
Do we need to write down the where R equals rate period?
yeah, I would. That's what makes these two different. This is the one the book uses, the second one. They use this one. I don't like this one. This is the actual formula. Again, I'll explain why. I don't like it, but I know Caitlin will have them, she didn't need to have them all written down, they'll be memorized. But make sure that you can find them somewhere. When I start explaining them, you might want to jot some things down. That's why I wanted you to skip a little space. Jot some things down with each one. And then you decide which one you want to use. I don't care which one you use, really. But you're going to have to make that decision. They're exactly the same formula, just I don't like what the book did with the formula because it confuses me. It may not confuse you. On this first formula, on both of them actually, the amount, this is your principal, what you actually put into the account. So what you put in, plus any interest that's on the account. So that's both of these. That's what A stands for, is the total amount in the account after a certain period of time. P is just your principal. That's the same for both of them. Do we really need 0.00 here?
No.
So those are sort of unnecessary. All right, notice the one's the same in both of them. All that one is taking into consideration how much money you put into the account to start with. So it's P times 1, well, that's just the principal again. Here, this is where the formulas change. The book, all year long, when we've had R stood for what? Rate. And now the book changes. In their formula, this doesn't stand, it sort of stands for rate, but it's not just the percentage rate that they give you. It's the rate per period. So what you have to do to find this R is you have to take the percent and divide by how many periods per year. So if it was quarterly, we take that percent and we divide by 4. If it was monthly, we divide by
Isn't that what the top one does?
12. And that's exactly what the top one does, except I write it out up here in this formula. All right, so that's why I like this one better, because this one tells you exactly what to do. Take R divided by N.
That one is.
Now Alex might not like it because, well, it's got more letters in it and it's all harder.
It's just a radio.
You still got to do this. It's just they're putting this in there. And again, that's why I don't like this formula, because it changes what R actually stands for. This N right here, N is the number of periods, which equals the number of years times the periods per year. That's the same thing as up here. N here stands for the number of periods in a year, or periods per year. I don't know why I'm rewriting this, because it's right here. So that N stands for the same thing as this N right here. T just stands for the years. How many years are we putting into account? Now the bad thing with T here is, bad thing for T is you have to remember sometimes we're not going a full year. So if I say 6 months, what are you going to put in there for T?
6 out of 12?
6 over 12, which is what? 1/2. Or 0.5. It doesn't matter which one. All right? This is the formula I would rather you use, because again, I think it's, that way we don't have to worry about what's R, what's N, which one are we talking about. This formula I would rather see you use than this formula. It's the same formula, just different setups for these two things right here. With that formula, if you have a calculator, grab it. If you don't, again, get one. We're going to just plug in here real quick so that you can see how to plug this into your calculator. Let's make up something here. What's your principal? How much money are you putting into this account? So let's do something sort of easy. Give me a number. How much money? $100? $100. What's our rate? Oops, let's not do that. What's our rate? 6%? Thought I heard. How many years are we putting into the account for? 10 years. And how often is this, I'm going to put it in there. How often is this going to be compounded?
Quarterly.
Quarterly? So quarterly means how many times per year?
4.
4 times. All we're going to do is we're going to plug all those into this formula. A equals, what's P? 1 stays the same. What's R?
6%.
Change that to a decimal. What is this, a decimal? 0.06. N is how many times per year? How many times did we say? N is how many times per year, so that's 4 times how many years?
10.
That's our formula. Now, when you're doing this on your calculator, and this is the part that I would highly suggest for your certain calculator that you write down. When we're doing it on our calculator, I would do that first. So grab your calculator and take 0.06 divided by 4. Once you do it on your calculator, don't hit any other buttons. Just hit .06 divided by 4 equals. Everybody with me to that point? Second thing, on your calculator, hit +1. And then hit equals. Don't hit anything else after that. Simon, are you trying this on your calculator so that you can see if...
I'm trying to figure it
He's
out right
reading
now.
his directions.
You don't, we haven't got to anything that you should need the directions
Oh,
for
he
yet.
doesn't even know what he's doing, so.
I'm not doing the calculator.
So do this, Simon. .06 divided by 4. Hit equals.
I'm writing down the rest of the equation right
Just do the points.
No, don't try to do it all as one thing. If you're,
now. There we go.
Divided by 4.
and hit equals. You got that number, right?
Yeah.
Now, second thing, hit +1. Should give you like 1.0 something, 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 something.
It just goes 1.015.
Okay. Then the third thing, this is where it's going to be different on each of your calculators. I'm not sure. The third thing, find on your calculator a button that looks like this. There's a little caret button on your calculator. See it? You're going to push that caret button, and then the fourth thing is you're going to put in this number. And you could probably do this number instead of trying to punch in 4 times 10. What is 4 times 10?
40.
So change it to 40. Don't try to punch in extra stuff. Then hit equals. Did everybody find that caret button on their calculator? Matt, is it on your phone?
I can check. I bet you it is.
It might be.
It's alright.
I see what you mean by
Maybe
this.
predict
Bad
that.
calculators aren't good for this.
Yeah.
No, I don't see it.
You can.
Yeah?
You can put it as, but I don't know if you can
Oh, wait, I see
exactly.
it.
This one is.
I still highly suggest that Matt, next time you get what?
A calculator.
Make sure you start bringing a calculator, everybody. Now, is everybody with me to that point?
Yes.
Once you have that, we've done all of this. Then all you're going to do is now the fifth thing. You hit times, and you type in whatever that number is, your principal. So just hit times and then that number, and then hit equals. What's it tell you? 0.40. What that's telling us is after 10 years, if we put $100 in an account at 6% interest, and it's compounded quarterly, how much money are we going to have in that account after 10 years? $181.40. Now the other thing, and this is going to be on the next slide, if we needed to figure out how much interest we actually earned, what would you have to do to figure out the interest that you earn? Interest would just be, how much money did we put into the account? $100.
And then
So,
you would just do it by your rate, wouldn't you, figure it out?
no, all you gotta do is, once you know this is how much is in the account after 10 years. How much did you put in? How much of this money is interest in?
81.
$81.40. You just subtract the amount in the account
Oh, I thought you were trying to find.
minus the total. Minus the principal, I should say. Simon, did it work on your calculator?
I can't find an exponent. Let me see.
We don't have to do it, buttons, or you can read it.
Yeah, but erase everything, put an E and K in there. I have no carrots.
Think you'd handle that? Jidlin, was it too hard?
Never mind.
Am I making it harder than it is? But you can handle it, right? You explain it to Elijah?
We just add the.
No, times by 100. So your last thing is times by that number, and that's going to give you the amount in the account. This other formula, same way, except the R and the N are something different. Again, I should just get rid of that formula probably and not even do it. This formula is not that difficult. This one's less strokes on, well, I shouldn't even say it's less strokes on your calculator, because you still got to do this and you got to do this before you even start the formula, which up here we just do it in the formula. I'm skipping over this. Two more little equations here. These are what we just said over here. The amount is the principal plus the interest. We just found that by using that formula. So this is using the formula. Remember, the amount, though, is the total in the account. If we just want the interest, then we got to take this answer minus the original principal, how much we actually put into the account at the beginning. Yes, Nick? You're probably not going to be able to do it. You're going to have to get a normal calculator. I figured it out. All right? Oh, yes. You gotta bump the decimal over two places, and up means multiply. Don't put percentage on them because they're not percents anymore.
I think I figured it out. That would mean like next place, right?
No.
Just told you.
Are you writing this down?
I was trying to figure out.
Are you writing this down? It's a yes or no question. Help him out, Colby. Tell him it's a yes or no question. I'll let Colby smack you here in a minute. Lane, did you look at this and you couldn't find that caret button? It's on here somewhere, I just hope you'll see it.
Whenever I did that, it had a kick with the.
Right, but it's got a caret with the E, and the E is a actual, you know like pi?
No.
When I tried to teach you geometry and I taught you about pi,
3.1419.
E is like that. E is a certain, a special number. I'll find it here in a second. I have to go get those slides. So nothing hard about these two formulas. This is, to do this, to find the amount, you're going to use the formula that we just covered, or you're going to use the chart, which I'm going to show you that. Maybe Alex likes the chart better, I don't know. It's going to give you the same answer. Compound interest, to find the actual interest, we take the answer that we get from up here and we subtract off how much money we actually put into the account. The compound interest table. I wouldn't write this down. Don't bother with writing this down. It's just telling you it's a tool to calculate it. That table that I gave you, the front side, notice it has two sides. The front side is the compound interest table. And what it tells you how much interest you earn on $1 for a certain number of periods. So looking at that table real quick, make sure you're looking at it so you understand this. Down the side, Simon, you listening? You better be focused, man. Didn't I say that earlier?
He actually asked me if we had to write that down.
Yeah, no, I just said that. On this table, down the side, the number of periods. That's the total number of periods. How many periods did we have this $100 in this account for? 40. You got to multiply those together, right? So it's 40. 40 periods. We look down the side. If it was 40 periods, we find 40 right there. What was our interest rate?
6.
Now what we don't want the interest rate per year. We want it per period. So you got to take that 6% and divide it by 4. Somebody help me out. What's 6% divided by 4?
0.015.
So 1.5% or 0.015, right? They leave it as a percentage along the top up here. Does it have 1.5% up there along the top?
Yep.
So now what we do, listen closely so you understand this, because you might think this chart's easier than that big long formula. And you might have to use the chart, because how long has Ebersole been telling you to get a calculator? About 4 months now?
Yeah.
And if you don't have one yet, it may never happen, I guess.
What about my spare?
So you may have to use the chart. So we go down to 40. We go over to 1.5. What's the number that's in the chart?
1.81402.
1.8 what? 402.
Yep.
This is the number from the chart. Now all you're going to do to use this chart to find the amount in the account is you take the principal times the number from the chart. What was our principal? 100. Grab your calculators again. 100 times, and we times it by that number that we found in the chart. Multiply those two for me.
Yeah. I'm not going to a website to figure out how to do an exponent.
What do you notice about that number and this number?
They're kind of the same.
They're the exact same number. So if you want to use the chart, that's fine. The bad thing with the chart is, does it have every possible setup on here? No. All right, so the chart works, and it's not too difficult if your setup is on here. If it's not, then you got to use the formula. Write this one down. This is what I just wrote down there a second ago. If you're using the chart, that's what you need. Second one we already wrote down, so you really don't need it. What are you gonna do, Simon?
I was about to write something, but John told me to start.
Once you punch in all that other stuff and you wanna get to the here, you'll have your answer on here, so it'll say your answer is somewhere. That's right. And you wanna do this. See this button that says YX, push it. And it'll take the answer to that certain power. You're going to take it to 40, just punch in 40. So,
I did ask you before I asked you that, and you said no.
it's not really, but it'll work as long as you do it correctly.
Yeah.
Alright, so you have to just use that button.
Do you have sets of probability today?
Do what?
Do you have to use sets of probability today?
Yeah.
I probably don't play that.
What?
I'm aware of what you say in there.
Okay, I have a, what's this features?
What do you mean what I say?
Noah, spill the tea.
I don't know what he's talking about.
What's happening?
Did I call?
Watching them notes.
Did,
I caused it. You both caused it.
You always do.
Grandma's giving you $1,000.
so on this, what I want you to do, let's just do this one together, because there's another one that I want you to actually do in your notes so that you can see it, but not this one. Grandma gives you $1,000 for your birthday. You deposit it in the savings account that earns 4%. That is compounded quarterly. If you leave the money in the account and never draw any out, how much will you have after 1 year, so on, so on, so on? Yes.
Why?
Yeah. I have her on.
She probably wouldn't even give me. It's on there.
No, I have her on, no, yeah.
Then again, I could, I was like, yeah,
Yes,
hopefully it's not take care of
I have
it.
her, I have her last one.
It's like 90 years old.
Right. So, let's do this one, let's use the chart. Let's forget the, we're gonna need the calculator, but let's use the chart. Just see if you like the chart. Again, I like the formula, but we'll use the chart. Simon, I gave you back your calculator, right?
Yeah.
So, 4%, that's our rate,
Of,
and it's quarterly, so what do we gotta do with that 4%? Divided by 4, so what is it? 1%. Is 1% on this chart somewhere? So for 1 year, how many times in that 1 year is this interest gonna get compounded? How many periods do we have, in other words? If it's quarterly, then it's 4. So we're looking at 4 periods at 1%. That's the number we're getting from the chart. And remember, slow down. Remember that our amount is going to be principal times that number. What is our principal? $1,000. Times, now, go down to 4. Go over to 1. What's the number?
1.0406.
Did everybody find that? Simon, right there. What'd you come up with? What is it? Nobody's going to help me now.
You can see that number there.
Just read it to me. 1040. 0.6. This is money, so what do we want on the end? So after 1 year, in this account, how much interest did you earn? $40.60. Does that make sense? Is the chart too difficult?
No.
It's not real hard, all right? Again, the only reason that I show you the formula is because the chart doesn't work for everything. Okay? It's got to fit on here, otherwise it doesn't work. For 5 years, what's going to change?
It's not gonna.
Instead of 4 periods, for 5 years, how many periods is it going to be? 20. How'd you get 20? You got to do 4 per year times the 5 years. So that's 20. So the periods would be 20. How much is the principal still?
1,000.
So 1,000 times. Now we got to find the number.
1 point.
What are we going to look at on our chart?
The first
1% again, and you go down to what?
20.
20.
So 1 point.
You don't have to divide like this first one, like 4
No, because we already got the 1%. So.
The 1%.
So that's what we're using here. The 1% told us that's on your top row of your chart. And we're going to use it every time. Okay? The periods is just how many times per the whole life of the savings account or whatever it is. So here it was just 4 because it was only 1 year. Now we leave it in there for 5 years. So it's 4 times a year for 5 years, which is going to end up being 20 periods. All right. What's the number again?
1.22019.
0 what?
19.
Did everybody see where Lane got that number from on the chart? Yes, no, maybe?
Yes.
What's that give us when we multiply it?
1,200.
Grab your calculator and do it. Let's go. Alex is up here complaining that we're on the same problem. We're on the same problem because you guys won't grab the calculator and do the dang old problem.
I think I would be able to do this one.
1,220.9.
It's the same thing with this.
Yeah.
Why is it the same thing, just moving the decimal?
It's 1,000.
Because we're multiplying by 1,000. So how many places are we moving the decimal? 3. Now is that going to work out every time?
No.
No, only if it's like 100, 1,000, 10,000, something like that. So now that you see that, we should be able to do this one a little quicker, right? We should be able to do those a little quicker, but how many periods this time?
40.
40 periods. Does everybody see how he got that?
Yep.
It's just 4 times 10, right? 4 times a year for 10 years means there's 40 periods. So on our chart,
Go down to 40. That's in the first.
we're at 1%. That's the first row or first column here. Go down to 40. And what's it say?
1.48886.
Multiplying by 1,000, just moving the decimal over 3 places, right? So 1488.86. About when you turn 65.
How old are we?
That's 65 now.
How old are you? 18?
4 times
4.
65.
So if you're 18 right now and she gave you, for your 18th birthday, she gave you $1,000, how many years is that going to be?
47.
47 years. What do we have to do with the years to find the periods again? Times it by 4.
158.
188. What do we notice? There's no 188 on here, is there? So can we use the chart?
No, you have to actually.
So now we have to actually use the formula. Let's come over here and let's do the formula. This goes right back to what we were saying just a minute ago. It's only $1,000, but You know, after 10 years, $1,400. That's not gonna mean a whole lot to any of you. Okay, so I got an extra $500 on this account, big deal. But hopefully after 47 years, maybe it'll be a little better. What's our principal? Grab your calculators and try this again. Simon can punch this into his calculator, make sure that I told him right. What's our rate this time? 4%, so I need to change that to 0.04 since I'm putting it into this formula. N stands for the number per year, so how many? N again stands for the number per year. T stands for the number of years, which is what? 47. Again, on your calculator, you're going to do this part first. That's first. What's 0.04? Don't even tell me the answer. I'm sorry, I just shouldn't ask that. You punch into your calculator, 0.04 divided by 4 and hit equals. Does everybody have that on their calculator? Matt, you could be trying it on your phone, see if you can get it to work. Oh, is it? Does everybody have that? Then hit, second thing, hit +1. And hit equals. Don't give up, Carly. Go back and do it again. We're only a couple steps in. 0.04. 0.04 divided by 4. Hit equals. Then just hit +1. You got 1 point something, 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 right? Now, the third thing is you find that caret button. Again, Simon, on yours it's different, right? You're going to use the YX button. And I'll even do this for you. We probably should have done this at first. That's 28. 4 times 4 is 16, plus 2 is 18. This is going to be 188. So then you put in 188. And then hit equals. Don't hit anything else after that. So everybody to that point. And then we're going to times that answer by what? Times by 1,000. What's it come out to be?
$5,995.8.
So just read me the numbers.
5,995.80.
0.80. So after, when you're ready to retire after 65 years, that $1,000 changed to almost $6,000. So now you got almost 6 times as much money in that account as you had when your grandma gave you the $1,000. Again, it doesn't seem like a whole lot. You're not going to put 50 cents somewhere and when you retire, have millions of dollars. That's not going to work. But if you can save up money, we put in this $1,000, then the next year you put in another $1,000. Is that going to build up over time? Yeah, a lot, and quickly. And the more you put in, as you get towards 40-some years, the quicker it's going to grow. The assignments on these 2 pages. Do me a favor, grab a paper towel, and I'll come around and spray your desk here in a second. What that math teacher told me 20 years ago or 30 years ago when I was in college was put $20 out of every pay into an account, I get paid 26 times a year. No, actually, I get paid 24 times a year, sorry. $480. If I would have stuck that into an account, $20 every pay, starting from when I started teaching, he showed me it, I would have had like $1.5 million in that account when I retired.
Was it really necessary to assign this pay?
I just got to stay that way. Today. That's good.
I think 2 pages.
Watch what Wes is doing if you write down that assignment.
Smart man.
Oh, so we're not doing the second page?
Do not do the second page up there. Just do the first page. We'll go with that.
I didn't know, I thought you knew it.
Unless you guys understand.
Don't do it.
I'll make this Jimmy a dollar. Bro, you want to hang out?
Didn't shake your hand.
I'm mad at it. I have to be back at the school at 1:04. I do have a game that day, but I have to be back at school
So, don't.
But it's against the
So Noah, tell me. What have I said?
I have no idea. I just got told I need to.